Okay, so you've got this amazing AI, right? It's like a genius. But ask it to do one very specific thing, and it just falls flat. So in this explainer, we're going to figure out how to teach it a new skill, but we're going to do it the smart way, efficiently, without spending a fortune.
All right, let's look at the problem head on. We asked a big, powerful AI model to write a simple product description. And what did we get? Well, it starts off okay, but then it just devolves into this rambling mess. I mean, you can see it right there. This is our starting point, and frankly, it's just not good enough to actually use for anything real.
So, what do we do? That's the big question, right? We can't just throw out the whole model and start over. I mean, retraining these things from scratch costs a fortune and takes forever. There has to be a better way, a more clever truck to get it to do what we want.
And of course there is. The answer is this really cool technique called parameter efficient fine-tuning. We're going to zoom in on a super popular method called LoRA and its even more efficient sibling, QLora. This right here is the secret sauce. It's how you get amazing results without that massive price tag.
Okay, so what on earth is LoRA? Well, the big idea is actually pretty simple. Instead of messing with the entire model, we freeze all its original knowledge. Then we plug in these tiny little adapter matrices that we can train. I love this analogy. It's like having a car. You're not going to rebuild the entire engine, right? No, you're just going to plug in a small tuning chip to boost performance. We only have to train the chip, not the whole engine. Genius.
And to really get why this is such a game changer, you have to understand the scale we're talking about. The model we're using, it has over 3 billion parameters. Yeah, trying to train all of that, it's just a massive, massive job.
But here's the magic. With LoRA, we're not touching those 3 billion parameters. We're only training about 2.6 million of them. That is less than 0.1% of the whole thing. It's just incredible. That's the power of parameter-efficient tuning. It makes the whole process way smaller, way faster, and a whole lot cheaper. But wait, it gets even better. We can push this efficiency thing even further with something called QLora, which is what we're actually going to use. It's a souped-up version of LoRA that uses even less memory. It loads the base model in 4-bit instead of 8-bit. And the craziest part? You get all that memory saving without really losing any performance. It's the best of both worlds.
Okay, great. We've bought our tool, QLora, but, just having a fancy tool isn't the whole story. Now, the real fun begins. We're going on a little quest to find the perfect settings, to dial it in just right to get those awesome results we want.
And for our experiments, we're basically going to be playing with 2 main knobs. The first one is called R. Think of it as the size or the power of our little tuning chip. The second knob is target modules. This one's super important. It decides where we actually plug that chip into the AI's brain. So let's start turning some knobs and see what happens. All right, experiment number 1. We're going to start simple, with a pretty standard basic setup. This is the kind of thing you see recommended all over the place as a good first try. So for this first go, we're setting that R knob to 8, and we're pointing our adapters only at the attention blocks inside the model. That's a pretty common approach. And you can see that gives us about 2.6 million parameters to train. So how did it do? Well, it's okay. It's definitely better than that rambling nonsense we started with, but it's not exactly production ready. I mean, look at this. It's for a vacuum cleaner, equipped with a dust container that can be emptied via a dust container. What? That makes no sense. It's a logical loop. You can't ship that. Okay, that didn't really cut it. So on to experiment number 2. The obvious next step seems to be, well, let's just make the adapter more powerful, right? So what happens if we just double its size? So here we go. We're cranking that R value up to 16. That bumps our trainable parameters up to over 5 million. But notice, we're still targeting the exact same place, just those attention blocks. More power, better results. Makes sense, doesn't it? Well, nope. Turns out that was wrong. Even though we doubled the trainable parameters, the quality didn't get any better at all. We're still seeing that same lack of detail, the same goofy logical errors. So clearly, just cranking up the power wasn't the solution. And this is where things get interesting. This is the turning point. The first knob, the power knob, didn't work. So it's time to mess with the other knob. This is our aha moment.
This is where we figure out what really works.
So let's tee up our third and final experiment. This is the big one. We're not touching the size of the adapter this time. Instead, we're going to completely change where we plug it in.
Okay, check this out. We actually turned R back down to 8. But here's the breakthrough. Instead of just hitting the attention blocks, we're now targeting all the linear layers in the entire model. Now, yeah, this does mean we're training more parameters, but the key isn't the number, it's the coverage. We're spreading the love across the whole model.
And the results? Oh, they are night and day. It's a total breakthrough. For that first product, the computer mouse, we finally get a nice, long, coherent description that actually makes sense. This is what we've been looking for.
And what about our vacuum cleaner? Remember the dust container problem? Gone. Completely fixed. The new description is logical, it makes sense, and this just proves it. The secret wasn't the size of the tuning chip. It was about applying it much more broadly to more parts of the engine. So we found the winning formula. Let's just take a step back and really hammer home the big lesson we learned on this little adventure.
I love this chart because it makes it so clear. That first bar on the left, that was us just trying to increase the power, the R value. Barely move the needle on quality. But that bar on the right, that's when we targeted all the layers. Huge impact. It's not even close.
And this table really puts a bow on the whole thing. Look at those first two rows. Targeting only the attention blocks gave us low quality, even when we doubled down on the power. But then, row 3, targeting all the linear layers, bam, high quality, and the cherry on top, that last row shows that using the super efficient QLora in 4-bit gave us the exact same high quality. It just proves how powerful and efficient this approach is.
So there you have it. The secret isn't just about raw power. It's about being smart and applying that power in all the right places. By targeting all the linear layers, you can get these incredible results using crazy efficient methods like QLora, which really just leaves one final question for you. Now that you know the secret to cracking this code, what are you going to build?